Hello everyone, I hope you are doing good. So today we'll be covering another question of our Blind 75 series. So the question of the day would be problem 1, that is two-sum. So in our problem, we have been given an array of integers, nums, and we have been given a target value, and we have to return the indices of two such values who add up to the target value. So let's take an example case as given. So our nums array here is 2, 7, 11, 15, and we have a target value, let's say t equals to 9. So at first we'll be discussing the brute force approach to solve this problem. So as we can see, while traversing this array, we can see we have a pair 2 and 7 that sums up to 9. So for such cases, we just have to return the indices. For this case, it would be 0 and 1. So the brute force approach would be to traverse our array nums and just keep track of the current element. For example, when we are traversing here, the current element is 2, and then we would traverse again like a nested loop, and for the second traversal, we would check if there exists the value that would be equal to target minus current. So target minus current for this case would be 7. So for the second loop, we would have to check if a 7 exists in these three values. So at the first element, we can see we have a 7 over here. So we can just, if we have the first loop, let's say for I in range n, we can store the required value that would be nums I, or I should say t minus nums I. This is the required value. Now we'll start a second loop for j in range, let's say I plus 1 to n, and we would check if nums j, the value of nums at index j, if it is equal to required. If it is equal, then we would just return the pair I comma j, else we'll move forward. So for this brute force approach, we could see that the time complexity of a solution would be O of n squared. So now we'll be talking about how we can make this problem efficient. So we would be using a hash map to do so. Just a second. Yeah. So for the optimal solution, we'll start with the hash map, and let's say we have a hash map D. What we'll do is, for every number in the array nums, we'll keep a track of the number that is required to reach the target value and its index, so that when we get that certain number, we'll have the index of its pair already recorded in a hash map. So let's take this example. Let it be 2, 11, 15, and 7. And let's say our target value is 9. So what our job is to maintain a hash map, and what we'll store is, we'll go to 2, okay? This is the 0th index. We'll go to 2, and here we'll say, like, what's the required value for 2 to come to the target value of 9. So here we'll store 9 minus 2, that is 7. And we'll store the index 0. Like, this would help us in a way when we move forward and look into another element, and let's say we find our target element 7 here at index 2. So at 7, we would have a note of the index of 7, and we would have a note of that index that would form a pair with 7 to give us the target value. So in our case, now we'll start traversing our array. For first, we'll keep the value of 7 and the index 0. Next, let's keep the value of minus 2. So, this is already greater than the target value, so it's obviously not possible to reach that value. By adding 2 values, if all the values present over here are greater than 0 or positive values. But we could have such cases when we have negative values in our array. For example, let's say if we had minus 2 just before 7, then we could have easily matched the target value using 11 and minus 2. So yeah, now we'll be looking forward, and we'll note the index of minus 2, that is target minus 11, and its index is 1. Now we'll go to 15, and we'll go to 15. We'll note the value. That would be minus 6. Note its index. That would be 2. Now we'll come to 7. Now we can see that we already have the value 7 stored in a hash map. So in this case, we would straight away return the index at which we have the value 7, that is 0, and the index of this 7, that is for our case 3. And for cases when we would not be able to find the solution, we'll straight away return an empty array. So now let's jump on to the code of our problem. So the first thing we have to do is maintain a hash map or a dictionary, and we'll just store our first target minus the value at the 0th index of nums as 0. So this is the same case. Here we stored 7 and 0th index. Now we'll start our traversal, and we'll say, like, for I in range 1, the length of nums, if nums I is present in our dictionary D, we'll straight away return a list of 2 values. The first value would be D of nums I, and the second value would be I. This is the same case. The first value over here was D of nums I. For this case, D of nums I was 7. So nums I, the value of nums I was 0. So we stored 0 and we stored I. I was 3 in this case. And for the cases where it's not in D, we just keep a track of target minus nums of I, and we'll give it an index value of I. If we are not able to find anything, we'll just return an empty list. So let's check our solution. So as we can see, it's a pretty efficient solution, and I hope you liked the video. Now I like to talk about I'll talk a little about the space and time complexity of a problem. So we're talking about the space complexity as we are using a hash map. The space complexity would be big O of n, and as we are traversing our array only once, the time complexity would be big O of n. So thank you and have a nice day.